Hello, my dear children, and welcome back. I know, the exams are just around the corner and the tension is building up. But listen, you have nothing, absolutely nothing to fear when your teacher is here. Today, we're going to dive into Chapter 1, Computer Systems, and I promise we'll make it so simple you'll never forget it. Now, make sure you subscribe and share this with all your friends who might be feeling that exam pressure too. And remember, if anything isn't clear, just pop a question in the comments below. I will reply to every single one.
Okay, so let's try something fun. Instead of just memorizing all those boring definitions from your textbook, let's do something different. For the next few minutes, you and we are going to be engineers. We're going to build a computer from scratch, right here, right now. It is truly the best way to understand how all the parts fit together. Cello, let's begin.
So, first things first. What exactly is a computer? You know, whether it's your smartphone that you use for scrolling Instagram or one of those huge servers in a big company that costs lakhs and lakhs of rupees, every single computer in the world follows one simple basic rule.
And this diagram, this is that rule. Think of this as our master plan. It's called the Input Process Output Cycle, or IPO for short. It's super simple. First, you give the computer some information. That is the input. Next, the computer does some thinking and work on it. That's the process. And finally, it gives you back the results, and that is the output. Simple, right? Input, process, output. So let's build our whole computer based on just this idea.
All right, so for that middle part, the process part of our computer, we obviously need a brain, don't we? Something that can do all the thinking and perform all the hard work. Well, in a computer, that part is called the CPU.
The central processing unit, or as we all call it, the CPU, is easily the most important chip inside a computer. Just like our brain controls everything we think and do, the CPU is the master controller of the computer. All the processing, all the calculations, everything happens right here. It really, truly is the brain of the machine. Now, this computer brain is so smart that it's actually made of two main parts. First, you have the ALU, which stands for Arithmetic Logic Unit. Think of this part as the maths genius of the class. It handles all the calculations, plus, minus, multiplication, everything. And it also makes logical decisions. Then you have the CU, the control unit. The CU is like the strict class monitor. It doesn't do the maths itself, but it manages everyone, directs the traffic of data, and tells all the other parts of the computer what to do and when to do it. So one is the genius and the other is the manager. Great. Our computer now has a brain. But what good is a brain if it can't remember anything? For that, our computer needs some memory. Now, this is really simple. A computer basically has two kinds of memory. Just think of primary memory as your study desk. It's right there in front of you, so it's super fast to get what you need, but you can only keep the books you are currently reading on it, right? It's temporary. Secondary memory, on the other hand, is like your big bookshelf in the corner of your room. It holds all of your books, it's permanent, but it takes you a little bit longer to walk over there and get the book you need. Okay, now inside that primary memory, there are two very important types, RAM and ROM. Beta, this difference is a very, very common exam question, so listen carefully. RAM is your main working area. It's what we call volatile. That means when you switch off the computer, poof, everything on it disappears. It's gone. ROM, however, is read-only memory. It's non-volatile. It holds the super essential instructions, like how to wake up the computer when you press the power button. The computer can only read from it. It cannot change what's written there. And these here are some examples of our bookshelf. That is our secondary memory. Your hard disk, your super fast SSD, the pen drive you use to copy files for your friends. This is where all your stuff, your games, your photos, your YouTube videos, and all your important school projects are stored permanently. Okay, so our computer now has a brain, the CPU, and it has memory, both RAM and storage. But how do we talk to it? And more importantly, how does it talk back to us? Well, for that, it needs senses and a voice. Let's talk about input and output devices.
बिल्कुल simple है. An input device is how you put information into the computer. For example, a keyboard for typing. An output device is how the computer gives information out to you, like a monitor that shows you the pictures and the text. So, one is for talking to the computer, the other is for the computer to talk back.
And guess what? You use these things every single day. Your keyboard and your mouse are input devices. When you're on a video call with your friend, your microphone is the input. The screen that you are watching me on right now, That's an output device. The speakers are your headphones that you're listening through, also output devices. See? You already know all of this. So, we've done it. We have built the body of our computer. The CPU, the memory, the keyboard, the monitor, all the parts we can actually touch and feel. This is called the hardware. But a body without a soul, without a mind, is just a useless machine, right? It needs instructions. It needs a soul. And that's where software comes in. Software is the magic. It's the set of instructions that tells all that physical hardware what to do. You can't physically touch software, just like you can't touch a thought or an idea. But it's the software that runs your favorite games, that lets you watch YouTube, and makes your computer a useful, amazing machine. Just remember, hardware is the body and software is the soul. So how does it all come together? Well, look at this chain of command. It all starts with you, the user. You tap on the Instagram icon. That app, Instagram, is called application software. Now, the app itself can't talk directly to the physical parts of the phone. It needs a manager, so it sends a request to the big boss, the system software. This is your operating system, like Android or Windows. Finally, the operating system gives the order to the hardware, the CPU, the RAM, the screen, to actually open and run the app for you. It's like a message passing from you to the app, to the manager, and then to the workers. And there you have it. We just built an entire computer system right here in our minds. You now understand all the basic components and how they work together. I think you are ready. Let's try an important question that comes up very often in the exams. Okay, here's the question. What is the need for RAM and how does it differ from ROM? This is a classic 3-mark question. Just take a second. Think about our study desk analogy and the wake-up instructions. How would you frame your answer? Here is how you can write the perfect answer to get full marks. First, clearly state the need for RAM. You can say it's a fast, temporary workspace that the CPU needs to do its job. It's much faster than getting things from the hard disk. Then, list the differences clearly in points. Point number 1, RAM is volatile, whereas ROM is non-volatile. Point number 2, RAM is used for the computer's current tasks, while ROM is used for permanent startup instructions. Writing in points like this makes your answer so clear and easy for the examiner to read and give you full marks. And we are done. See? That wasn't so difficult, was it? Computer systems is actually quite logical. You just built a whole computer, and you even learned how to score full marks on an important exam question. You are absolutely ready for this chapter. All the very best for your exams, children. Don't forget to like this and share it with your friends. And if you have more questions, you know where to ask. I will see you in the next one. Bye-bye and take care.